Hello guys, we're back again. We are doing algebra. We're doing algebraic expressions. Excuse me. So in these algebraic expressions, on our previous lecture, on part 4, we're now on part 5. On our previous lecture on part 4, we had discussed very important things about what is it that makes up or that constitute an algebraic expression. We said we are using a coefficient, we are using a variable, and we are using a constant. And of course there is number operations. And we also mentioned that there were three types of algebraic expressions. The first one was a monomial, the second one a binomial, the third one a trinomial. We discussed that. And now we are about to discuss how to use expressions. So now I am talking about combining algebraic expression. Is what they normally ask you, for instance, they would give you an expression and ask you to simplify. If you may notice, I'm on lecture number 5 now. I don't really use examples like most people do. I'm only giving you the rules, the properties, the laws, the fundamentals, the enablers for you to be able to perform algebraic operations. So my work so far, I can say about 90% of it, I'm just using general form, meaning that I use variables. I don't really do examples. I'm sure you understand what I mean. There's a specific reason why I'm doing this. I have realized that most of the times the learners, they tend to focus more on the examples to a point of wanting to remember a specific problem, how it is done. And that is wrong. And that is what you do with most of your revision work. You revise question papers, previous question papers, and you expect to get them in your examination or your assessment. That can never happen. If it happens, maybe it's just less than 10% chance for it to happen. You will never get something that looks exactly the same. But you will be asked about algebra, you will be asked about functions, you'll be asked about trigonometry, you'll be asked about calculus, you'll be asked about financial mathematics. All those things, geometry, etc. All those topics, they have their own governing dynamics. They have their own laws, a set of laws, set of rules, set of procedures, set of principles, which you need to understand. Once you understand that, you don't need to worry about anything else. Once these principles that I'm showing you, you put them in your head, in your head, you'll be like a person who's carrying spanners screwdrivers, shifting, all types of tools. You'll be able to open anywhere. These are the keys. For real, I am giving you keys of algebra. That is why I'm not solving problems. I am showing you how to do mathematics. And I want you to be able to understand mathematics by following the rules of mathematics. It's very crucial. If you do what I'm telling you, and then you go to your textbook and try to answer the questions that are relevant to the work that we've done so far, you will see that you have the ability to answer. Why? Because you have captured all the governing dynamics. Okay. Now, I'm going to talk about combining algebraic expressions. When we combine algebraic expressions, remember, from lecture 1 up to lecture 4, I have been showing you guys the rules, the fundamentals, the principles, the procedures of how to do algebra and how do you work with algebra. Now, I told you that these things, they will all come back automatically, and you will find them. You will really find them on expressions. So now, we have learned about properties of real numbers, where we spoke about distributive property, associative property, and commutative property. We did the exponents, we did a lot of things, but something keeps coming back. Properties of real numbers. Why? These three properties, they enable us to do algebra. For instance, when we combine algebraic expressions, we add or subtract polynomials, we'll have to use real number properties of real numbers. They become applicable, these real number properties. You can't go through without them. That is why I started there. Secondly, when we combine algebraic expressions, we combine like terms. What are like terms? Similar variables. You combine x together with the same power, of course. Same power. You combine them. Same variables with the same exponent. You combine them. It's either you are going to add or subtract them. Yes, you are allowed, in certain instances, to multiply same variables with different exponents. And there comes laws of exponents. That's actually law number 1. Same basis, you add exponents. You may also divide them. But you may also multiply variables that are totally different from each other, also with different exponents or similar exponents. Does not matter, because nothing happens. You just get a product of x and y, if we were talking about x and y. So you must know that. Don't do as you please. If you want to be good in mathematics, you follow the rules. You'll never go wrong. There are guiding principles here. Thirdly, you simplify. You can see my example on number 2 here. I added 5x to the power 7 with 3x to the power 7. So these numbers, because the variable x to the power 7 is common in both of them, so I am adding 5 and 3, and then I'm getting 8 to the power 7. So in this case, I had to add. But what could have happened if it was x to the power 6 and this power was 7? I was not going to be able to add these things. Not at all. The reason why I'm able to add or subtract, the powers of the variables are the same, and the variables are also the same. Okay. Let us move to the next slide. We are talking about the product of polynomials. Product of polynomials. I hope you can see this distributive property keeps coming back. The properties of real numbers, they come back again and again and again. And when we are doing mathematics for quadratic equations, once we do quadratic equations, real numbers, types of real numbers, they also come back. Why? You are required to analyze the nature of roots. And when you analyze the nature of roots, you must be able to identify if they are rational or irrational or perfect squares. You must be able to do that. So I am asking you to build up. You mustn't do this thing of study, cram, and pass. It's wrong. You must study to understand things and be able to use them, because mathematics is practical. Very much so. And mathematical ability is important. Okay. On the product of polynomials, you can see here, we are multiplying here. What are we doing here? It's a distributive property. We keep doing it repeatedly. And you must remember, when we multiply, we first start with the first terms on both brackets. First terms. We multiply A and C, we get AC. This is the first term. That is why we put F here. And then we come again. Is the first and the last. So is the outer. We multiply the outer. A and D are outers. We get AD. Now we do the inner. We multiply the inner. B multiplied by C. BC is the inner. And D multiplied by, and B multiplied by D. These are the last terms. We put L, the last terms. So we come up with the word foil. Can you see? Foil. Everybody knows a foil. You wrap your sandwich with a foil. We always use foils at home. Okay. This is it. I'm not doing examples. You can put your own variables. In the place of A and in the place of C, you can put X, and in the place of D and B, you can put maybe 2 and 2. Just put the numbers and work it out yourself. And use FOIL. FOIL. It will make you remember easy. Let us move to the next slide. Alright. We are now talking about special product formulas. When we multiply the difference of A and B and multiply it with the sum of A and B, use the FOIL. Apply the FOIL method. You will get this. You will see that if you multiply A and A, you'll get A squared. And you multiply A and B, you get positive AB. And then you come again, you multiply the inner, negative B times A, you get negative AB. This positive AB, subtract negative AB, it gives you 0. And then negative B multiplied by a positive B gives you a negative B. You see here, there is a distributive property that is done repeatedly. Number 2, there is properties of negatives. We are multiplying positives and negatives. That is why I'm saying, when you do algebra, you must bring all the set of laws, all the principles, all the fundamentals, all the properties. Bring everything. Bring all the tools. What we've learned in lecture 1 to 4, it was a toolkit that enables you to solve problems. On number 2, you have A plus B all to the power 2. What do you need to do here? What does it mean? A plus B, it means you can open 2 sets of brackets. Now remember exponents. We said exponents, they tell us how many times the base must multiply itself. In this instance, the base is the sum of A and B. And for you to be able to simplify this, use FOIL. You multiply the outer, the first terms first, A and A, and you multiply the outer, A on the first bracket and B on the last bracket, on the second bracket, and then you multiply the inner, which is the B on the first bracket and the A on the second bracket. And lastly, you multiply the last terms, B and B. You do your algebra, you group your like terms together. Remember, that's the first thing we spoke about. You group the like terms together. You add or subtract like terms. You do the same thing here. You see the rules? They apply now. Without the rules, without the laws, without the principles, you will not be able to do this. Number 3. We have A subtract B, or a difference of A and B, all to the power 2. Again, you open 2 brackets because A minus B, in this instance, it is a base. We bring back the laws of exponents. So the exponent 2 tells us that the base A minus B must replicate itself. So you open two brackets, two sets of brackets. Inside them, you write a minus b and a minus b. You use the FOIL method, the one that we did on the previous slide. Similarly here, on number 4, you apply the rules of exponents. You do the same thing. You multiply throughout. So you see, for you to be able to work with special product formulas, what do you need to understand? FOIL. Is there anything else? Yes, it's FOIL together with, I think, now more than 15 rules that we've done. Yeah, they must be here. Here I see exponents, I see distributive property, I see, lot of things. And the rules that we just learned about algebraic expressions. On number 5, you also do the same thing. Okay. Right. I'm moving to the next slide. The next slide, we are talking about factoring. We need to understand this word, a factor. What is a factor? Can anybody tell me what is a factor? A factor is a number I need to put R there. Okay. Is a number that divides another number without leaving any remainder. No remainder. That is a fact. You take any number, you divide it with any number. If you don't get a remainder, that number which you use to divide is a factor of that number. Are we clear? So, if I take 6 and divide it by 3, the answer is 2. There is no remainder. 3 is a factor of 6. You can try your own examples. You'll see. We use distributive property reversely when we do factorization. Really. We use it reversely. So you must look at this difference of two squares, x squared minus 4, and I want to express them as the difference of two squares, meaning that x is squared and 2 is also squared. We now follow the rules of exponents. It means we have 2 x's and 2 2's. Why? The exponent tells us how many times the base must replicate itself, and therefore I open two brackets. I write x minus 2, and then I write x plus 2. This is because it's a difference of two squares. Okay. When you multiply and use FOIL, you'll get exactly x squared minus 4. So I've shown you with arrows when you move from x squared minus 4 to two sets of brackets where we have written x minus 2 and x plus 2, that is called factorization. And backward is called expanding. I want to do factorization of trinomials. I'm going to show you how trinomials are factorized. Okay. So I'm going to make a note here. Rate in rate. Factorization of trinomials. Factorization of trinomials. There is high demand for the factorization of trinomials. You find a lot of them in algebra. So let us talk about factoring formulas. Factoring formulas. A squared minus b squared. When you factorize them, you get a minus b and a plus b. This is called a difference of two squares. Now you need to understand these things and know the names of these expressions. It's important to know the names of these expressions. You look at the structure, you can see and be able to name it accordingly. Number two, you can see is a trinomial. The first one is a binomial. Number 2 is a trinomial. So a squared plus 2ab plus b squared is a perfect square. Is the sum of a and b all squared. Similarly to number 3 is also a perfect square. A squared minus 2ab plus b squared is equals to a subtract b all squared. Number 4. Here we're talking about difference of two cubes. Difference of cubes. So is a cube subtract b cube. It is equal to a difference of a and b into a squared plus ab plus b squared. This is the structure. You must understand this structure. So how did we get this ab in between? You simply multiply a and b. You multiply this a and this b, you get a and b. This is the difference of cubes. We also get the sum of cubes. It's the same thing. The difference is that there is a plus sign. Right? So you must notice that here we have a negative sign and here it's positive. So if it's negative here, if it's positive here, then it's negative. So this is the sum of cubes. Let me just go back into this slide and show you how to factorize a trinomial. There are rules in the factorization of a trinomial. This is a difference of two squares. A trinomial. Let me just think of a trinomial. A trinomial, what could it be? I'm thinking of x squared minus, okay, let me think, and if I put 6 here, and I put 5 there. Yeah. All right. How do we factorize a trinomial? First, we look at the exponent of the first term. It is squared. Therefore, I will open brackets. This tells us x will replicate itself. So we have two x's. There you go. Okay. Now we are looking for factors. We're doing factorization. What are the factors of 6? Step 1. The factors of 6. Multiple factors. Multiple. Multiple factors. Right? In the multiple factors, let me just write it nicely. Multiple factors. So we're going to factorize. We're looking for the multiple factors. You know, while we're still here on the trinomial, when you get to grade 11, and those who are doing grade 11 and grade 12, they know, sometimes it becomes impossible to factorize a trinomial. Then we use another method, which is called completing a square. But for now, you can still factorize. Nothing is complicated so far. Everything is going smooth. With the build-up, even when we get to the stage where we need to complete a square, we're going to do it with ease. The reason being, we have the proper foundation. Okay, so we are looking, let me just clean these dots here, my board. What are the multiple factors of 6? We are looking for multiple factors of 6. 1 multiplied by 6 is equals to 6. 2 multiplied by 3 is equal to 6. Note, I'm counting in order. 1, 2, 3 multiplied by 2 is equals to 6. Number 4. There is no number which I can multiply with 4 to give me a 6, so I jump. Number 5. There is no number which I multiply by 5 and give me 6. The last one, 6. I can multiply it by 1 and still give me a 6. Okay. There you go. We have 1, 2, 3, 4. 4 multiple factors. What do we need to do now? We must look for multiple factors that when we add or subtract, they'll give us the value of the middle term. What did I say? Amongst these multiple factors of 6, you must search for a combination that when you add or subtract will give you the value of a middle term. Middle term meaning 5. So 1 plus 6, it's 7. We don't want it. 2 plus 3 is 5. It makes sense. It looks like a middle term. 2 plus 3, 3 plus 2 is also 5. 6 plus 1 is 7. So we only selecting these two, and therefore what is the sign here? It is positive. What is the sign of 3? Is also positive. It is also positive. Okay, so we take them as positive. Positive 2, positive 3. Okay, in this instance it does not matter because we are not doing any subtraction. But if there is any subtraction, let us say maybe we had to subtract 1 minus 6, you'd get a negative 5. 2 minus 3, you'd get a negative 1, and 3 minus 2, you'd get a 1, and 6 minus 1, you'd get a 5. So in this case, there was no need for us to subtract. We were only required to add, because on the middle term is a plus sign, on the third term is also a plus sign. Now, this is the answer. We have taken the combination. You don't have to worry and all these things and say, hey, it's difficult to factorize this and that. No, man. You must look for the factors of the last term, multiple factors of the last term. List them down, add them, and subtract them. From one of those columns, you are going to get an answer corresponding to the middle term of the trinomial, corresponding in terms of the numerical value, the quantity, and also the sign, whether it's positive or negative. You choose that combination. and you bring it as it is together with its signs on the brackets. So this is how we've done it. If you use FOIL here, it will go back to this. So FOIL is our friend. Guys, please like my video, give me thumbs up, share it with your friends so that they can also gain a better understanding. I hope you really do get the fundamentals which I want you to receive, so that you will be able to perform mathematics at any given moment. Thank you.